In terms of safety and costs, snow and ice rank among the biggest enemies of transportation departments nationwide. For years, those who fight this recurring problem have dreamed of an ability to make a preemptive strike, a chance to get out ahead of the storm. Now we can, by using a Road Weather Information System, or RWIS. It's a system that integrates a variety of information, providing an up-to-the-minute decision-making tool. More precisely, RWIS is a road weather monitoring and prediction system employing real-time sensor data, historical weather patterns, and computer models to forecast specific adverse pavement conditions. With a road weather information system, snow and ice maintenance managers can improve their allocation of labor, equipment, and materials. The result? Rapid, cost-effective, and preemptive responses to adverse weather, and improved conditions for drivers. There are 5 basic elements to a road weather information system. Weather observations by highway agency and weather personnel. Weather and pavement sensors to measure important variables such as temperature. Communications of forecasts and sensor data to people needing to use it. Support equipment, including remote processing units, computers, printers, and communication networks. And tailored weather and roadway forecasts by professional meteorologists, which are optional but valuable. Now let's see how RWIS can work. This is the home of the Stevens family. Right now, Susan Stevens and her daughter Rachel are getting ready for a very important trip to a special championship swimming meet. Their state has just installed an RWIS. Larry Casey is a Snow Control Center operations manager. He and his assistant, Jose Granados, have worked with the system through the past winter. Because the system is still relatively new, several district superintendents are still skeptical. Rich Patterson is no exception. He's been trained on the system, but is having trouble getting used to new ways of doing business. Part of the new way includes a contracted weather forecasting service. Pat Healy, as we'll see, works for the service and stays in close touch with state personnel.
This is Rusty Steele on WQRF. I'll be back in a moment with the forecast right after this.
Rachel, I've got a suitcase for your trip. Have you picked out your clothes yet? Rachel, did you hear me?
I sure did. I packed last night, mostly.
Oh, Rachel, you're getting ahead of yourself, honey. We've still got a few days. I know you're excited about this trip. You've been talking about the championship meet for over a month. But our plane doesn't leave until Friday.
I had a dream last night. I came in first in the backstroke. I can't wait. This is going to be great. I wish Dad could come.
So do I, honey.
Here's the forecast. The National Weather Service has a major snowstorm will hit us by this weekend. Sorry, kids, I guess you won't have a chance to get out of school, but at least you'll have some fun on the weekend. Present temperature, 43 degrees. The wind's out of the southwest.
This could be a problem. The roads we have to take to the airport, they're clogged in the best of times.
What do you mean?
Well, what it means, honey, is that we have to make our flight. We can't miss it. Our tickets aren't refundable.
Miss the plane?
Don't worry. Our flight isn't until Friday, and it's not until the morning, and it may not snow by then. But what I want you to do is turn around and get your dirty clothes out of your suitcase so I can wash them.
It was definitely this weekend that storm's coming in. I saw it on the tube last night. I'm going to give Pat Healy a call and try to pry some information out of her a day or two early.
Good idea, Larry.
Hello, Pat. This is Larry at the Control Center. How are you? Good. Listen, I was watching television last night, and I'd like to get some advance information on the storm coming in this weekend.
Well, we've been tracking that storm right along with the Weather Service, but I really don't have too much to tell you yet.
I know you usually don't like to give information out until 24 hours before the storm, but come on, Pat. Can't you give me something off the record?
Well, off the record, let me see. I think your state's going to get between 2 to 4 inches of snow, falling about an inch per hour. You might even get some ice. It's going to start probably around Friday afternoon in the northwest part of your state.
Thanks, Pat. Jose, we better start checking early tomorrow morning. They say Friday afternoon, 2 to 4 inches.
I could double check that information by noon and then let the supervisors know so they could plan their schedule.
Yeah, I have a copy of the latest forecast here, Larry. And, you know, it is March. You're talking about a lot of people who are going to be affected by this here. I mean, you know, just because some computer dreams up a forecast.
I know what time of year it is, Rich. But we've got very good information these days. We've got the sensors all over the region. In fact, you can take home your laptop and check them yourself. And we stay in contact with the neighbors to the west of us. And then there's the contracted weather service. They're constantly checking all that information too. In fact, I just received another forecast. Hold on a second, Rich. Based on new data, they now predict the storm will start in the northwest corner of the state, proceed east-southeast at 20 miles per hour. Pavement temperature is expected to drop below freezing at 2 a.m. and stay there the rest of the day. They say it'll be here Friday, 4 a.m., 4 to 6 inches, Rich. I've got to get this information to the other snow supers.
Larry Casey will advise maintenance supervisors immediately. Anti-icing applications will start about 2 hours ahead of the time they expect pavement icing.
And remember your promise, Rachel, you'll be home early tonight since we're leaving tomorrow.
Mom!
Hang on a second.
The TV, it said snow tonight. Well, late tonight.
What time did they say exactly?
I don't know. Wait.
Oh, great. This is all I need. We haven't finished packing. I still have laundry. What if the traffic's a mess? We can't miss this flight. We've got to make it. I know.
He said 4 a.m., 4 to 6 inches, and they showed pictures of the snowplow and stuff getting ready.
Hi, Al. How's it going?
Fine. How you like your new job?
Oh, I like it a lot. It's great. But sometimes I'd rather be out here where it's all happening, you know? I'm not really sure I trust the new technology too much. They tell me it's great with the computers and pavement sensors, and look at this. They even give me a laptop to take home with me so I can check the weather.
Yeah, I hear we might get some snow.
Yeah, we might, but if we do, I'm going to have to keep track of it, so I'm going to need some sleep. So I got to go. Take it easy. Okay, let's see what we got. I'll be still the same. Sensors 33 degrees Fahrenheit and dry. Air temp 31 degrees Fahrenheit. Friday 4 a.m. I guess I get about 5 hours sleep.
What's the story, Jose?
Let me check. Pavement sensors average 31 degrees, air temperature 29 degrees, and the wind appears to be shifting from southwest to west. Forecast is the same, 4 to 6 inches starting around 4 a.m.
Good. Are the crews out salting yet?
They should be heading out any time now to do their priority routes. They should be done before the storm hits. Here it comes. That last forecast was right on.
What is it?
Based on the temperature, it's sleet or snow. They're all registering it, one by one, all the sensors in the northwest region.
Let's keep an eye on those readings. I want to stay ahead of this thing.
Okay, Larry.
Let's send out the rest of the plows. Snow control, Casey. Yeah, we know. Our sensors picked it up. How fast is it coming down? Is there any accumulation yet? Okay, thanks, Rod.
Ice alert, Larry. Up north, on the parkway.
Thanks, Jose.
The system has followed changing conditions and warned ice is about to form.
Rich, this is Larry. Yeah, I told you this gear works. Listen, our equipment shows icing conditions up in your area. I want you to reapply chemicals on the parkway right away. They got a mobile phone? Good. Yeah, more technology. Well, how much snow you got up there? Okay, thanks, Rich. They've got 6 inches already, and it's still coming down.
It's really coming down.
Well, how's our street?
All white.
Well, the main road should be better. The radio said rush hour traffic was moving.
Crew in the Heights says they think it's slowing. What's the official word?
Let's see. Air temperature 30 degrees and has been falling. Wind west 0 to 5 miles per hour. Some air sensors report no precipitation. Mostly chemical wear areas. No ice alerts.
Well, that's good.
The forecast service says that it should end by 8:30 a.m.
Well, there's 7 inches out there, but it's not on our priority routes.
I had another dream last night. I was doing the freestyle, and somebody was in front of me, but I came in first because I did a better turn.
The dramatized situation you've just seen is already happening in many parts of the country. It will soon be commonplace anywhere there are snow and ice problems. The reason is the Road Weather Information System, or RWIS. Let's look at our scenario again from a different perspective and see how the RWIS system was put in place and how it works. Months earlier, the agency contracted with a professional weather forecasting service. Next, the agency arranged for thermal mapping of strategic and priority routes. This provided a plot of temperature versus distance, or thermal fingerprint, showing the hottest, coldest, and average sections of a roadway to help in placing sensors and forecasting pavement temperatures. A second benefit is that it can indicate which roads to plow or salt first. Some agencies have found that their experienced crews can provide this information using their experience and knowledge of local road icing characteristics. Armed with maps, information from experienced personnel, and more, they began installing the sensors. Sensors have 3 purposes. They help forecast surface temperature by providing real-time information. A computer then projects changes over the next 6 to 12 hours and even indicates the time when freezing will occur. The sensors monitor existing situations as well, again providing real-time data. And they detect critical events such as ice or a change from dry to wet pavement. There are 2 basic kinds of sensors, pavement and atmospheric. Optional placement locations for pavement sensors include on or below the pavement, least or most traveled lane, in or between wheel tracks, and sun or shade areas. They should be located at known trouble spots. Location of atmospheric sensors is similar to pavement sensors. They are generally kept near pavement sensors, but not too close to the road. Their surroundings should be grassy and unpaved, and there shouldn't be obstructions affecting wind and precipitation measurement. Field data must go to a computer, and from there to forecasters, maintenance managers, and crews. That requires a communication system. Sensors connect to a remote processing unit which communicates with the central computer at snow control headquarters. All of this equipment was already in place when the Friday snowstorm hit. In fact, the central computer had been continually providing the weather consultant with real-time sensor data. Earlier data provided the basis for the weather consulting firm's predictions before the storm hit. Based on computer screens showing state or regional maps and even priority routes, Larry Casey and his people planned a route-by-route anti-icing treatment. All this, remember, Casey did on Thursday, a full day before the storm was expected. When the storm was closer, sensors told him exactly which roads were nearing the freezing point based on temperature and salt concentration. When the storm actually arrived, everyone was ready. In fact, icing conditions were avoided through anti-icing treatments. The Road Weather Information System predicted which routes were in danger of freezing, and Casey and his crews reacted in advance of the problem. Anti-icing, spreading salt or other de-icing chemicals in advance of ice occurring as opposed to de-icing, is the subject of another SHRP project. The study found that up to 90% of the chemicals required to de-ice a road section could be saved if they were applied in advance of the ice occurring. What this requires, however, is accurate and pavement-specific weather forecasting and a road weather information system. System computer models provide pavement condition forecasts up to 24 hours in advance. Road weather information systems now make anti-icing a viable and cost-saving process in many cases. As the storm continued, sensors indicated chemically wet conditions, demonstrating the maintenance crews had done their job adequately. In fact, pavement sensors told Casey of changes in concentration of de-icing chemicals, as well as when temperatures fell below freezing. Atmospheric sensors detected precipitation and measured wind speed and direction, air temperature, relative humidity, and dew point temperature. Right up until the end of the storm, sensors continue to monitor the weather for conditions such as icing, minor snow squalls, and blowing snow. In this way, crews could immediately react to changing weather patterns before they became problems. The real benefits, however, are improved traffic flow, reduced fuel consumption, reduced unproductive crew time on the road, reduced accidents, and decreased insurance premiums. Let's look at the costs and advantages at various stages of building the system. Professional weather forecasting is the most important part of a system. A private forecasting service may cost as little as $25 per day per district. It can save much more than that by avoiding just one crew call-out. An initial group of pavement and atmospheric sensors will provide detailed, site-specific information on temperature and icing. A set of pavement and atmospheric sensors, together with remote processing equipment, costs about $40,000 per site. Each sensor added to the system provides some additional value. First installations will have the highest benefit-to-cost ratio. As you continue to populate a state or region, however, the incremental value decreases. Each highway agency must determine its own sensor benefit cost curve and decide how many sensors it will install. An integrated system incorporating weather forecasting service, strategically placed sensors, and an aggressive active maintenance action plan will provide excellent benefits over costs, and you can achieve a 20% increase in the level of service to the public. It will also reduce errors or bad decisions in calling out salt or snow crews by up to 90%. Everyone knows that if you call out crews for treatment and it doesn't snow, you've made a bad decision and wasted taxpayer dollars. And if you don't call out the crews and it does snow, then you've made an even worse decision, which costs a lot. A road weather information system dramatically improves the odds of making the good decisions. Soon there will be even more help in the form of what's called a weather prediction expert system. Using information from RWIS sensors, radar, and other field sources, it generates customized forecasts for specific local areas. These forecasts appear on an easily interpreted display 18 hours in advance of a storm. It's user-friendly and graphically displays or prints topographic elevations and road information as well as weather. The system can show statewide information or zoom into specific areas, regions, cities, and even priority routes. What does all this mean? Well, SHRP studies make several important recommendations. If an agency has significant snow and ice problems, it should use professional meteorologists. They will provide customized weather forecasts that will be locally specific. Agencies should locate sensors carefully and consider the potential benefits of thermal analysis. Agencies should provide specialized training for decision makers and forecasters. They should retrieve data from sensors at least hourly during critical periods. And agencies should set up annual maintenance programs for road weather information system components. SHRP has produced 2 reports to assist agencies interested in RWIS technology. One is a summary of research findings. The other is a guide for implementing a complete road weather information system. With a road weather information system, you'll have improved site-specific forecasts for weather conditions throughout your region. In addition, with real-time data, you'll be able to identify and treat trouble spots, immediately improving travel conditions for users. You'll reduce chemical use with predictive information and anti-icing treatment, thus saving money and minimizing environmental impact. In short, a road weather information system will help you get the right equipment and material to the right place at the right time. And you'll save money and lives. For more information on road weather information systems, contact SHRP or FHWA at the numbers shown on the screen.